Hello, my fellow YouTubers. This is Roy back again. Enjoy the night, enjoy the video. Let's rock this. He's an old timer right now. Dobermans this big usually last about 10 years. He's 9. Poor Vinny. Well, tonight is a video that hopefully you guys enjoy. A couple things, demonstrations I want to explain to you in deep detail. Visually. Obviously, you can tell the difference when you add air. Let's widen the gap right now. And the next demonstration is going to be awesome. This demonstration is going to involve a piece of rebar, and I got the end connected to a piece of wire. We're going to take this triple LED Germanium full wave bridge rectifier I got set up. I got a complete copper loop on one end. I am going to connect this end together, and we're going to go probe the ground and see if we can get the LED to light up. On this experiment, I want you to take notice of one thing. Is first, before I connect the metal to that light, we're going to put it in my hand, and we're going to walk off from here when it's lit, and we're going to count the nodes going out. I think there's like 2 or 3 nodes. And it'll be a place to where we're walking in the backyard where it doesn't light up, and then it'll light up. And as it lights up, we hold it up higher, the brighter it gets, and then as we go lower, all of a sudden it goes to nothing. And from about 4 feet to the ground, there's an area there that it will not light up. And that's where the probe comes in, because we stick this in the ground anywhere and it lights up. So on this experiment, very important experiment, is pertaining to that there's a place that the ground surface becomes 0, the lowest potential. As much as, in my eyes, as much as it's the lowest potential, it's also potential for the greatest. I see a flip to the coin here. You know why? Because they say that the ground relates to zero on the potential, and the stratosphere is the high potential. And you got to question that and saying, okay, there's your reference points. But what if you were to go from ground and go down? Does it substantially increase as well? And it does in negative energy. And this where Ed Lee Skowron, Tesla, this is Tesla. Right now, tonight, what I'm about to show you guys is walking in a pair of shoes that Tesla once wore. And I'm at a level now to where I can do things with the ground. And this is our nighttime experiment, because there's, you can't see at night, but basically you'll see the light real good, and you'll see the version of where the light will show us, right? It'll show us the energy, the nodes. It'll show us where everywhere in the ground you touch is a potential. And the fact that from the ground zero up about 4 feet is where the light starts. And as you go up, it goes brighter and it becomes potential. So it goes to show you there's a place right there that's a dense insulation, the dielectric of all dielectrics. And it's a combination of oxygen, water, and nitrogen. And let's get this party started. So right now we're going to, I think we're good, huh? Just leave it just the way she sits. The little piece of metal, it's aluminum hanging from a string, and it will pick up any direction in electrons, and you can see there's an electron vortex. And that's one thing I want to show you in the midst of all this. You ready? Oh, one more thing. So, take notice that when I put this, this is 15,000 volts, 60 milliamp, 7 beer bottles. I keep blowing these other cherry bombs. It's crazy. Nanofarad each, so that's 2, 4, 6, 7 nanofarads pumping with 60 milliamp into the ground. The thing is, tonight's real true experiment as well is out of phasing or out of phasing. And tonight in 4 hours of experiments, I realized that the Tesla coil itself is one part of the phasing and the grounding is the other part. Well, the thing here tonight, the first thing we'll do as an experiment is these 1, 2, 3, 4 grounding rods aren't connected here. The bottom of the secondary, which is the inductive field, which becomes the frequency of what I'm pushing. Okay, I'm about 720, no, my bad. I'm about 420 kilohertz. The bottom of this secondary comes down and goes to this wire. This wire goes out and goes over. It's not touching ground anywhere until I get to my little pile here. I had my well go down and I got an abandoned well. All of a sudden I got to get a new well. So in this well area, my pipe's underground for some stupid reason instead of above ground. It goes 90 feet. So I'm connected to that. So we got galvanized pipe going 90 feet deep into a water supply that has flow in it. Think about what's going on here. So now, pyramids, must I say? Leave your comment. So the wire comes up, not touching ground anywhere, comes up, comes over, and basically we're activating the ground right now. And I want you guys to appreciate this. This is basically everything that Tesla was working on in bigger scale. And doing it on the smaller scale is really exciting because I can't possibly kill myself this way. Let's fire it up. First experiment, we're going to put LED to the ground. You're going to see sparks coming off these pipes at the bottom. Nothing's connected to them. So in phasing, that means that the top load and the relationship between the top load and the primary is sequenced at a proper time to bounce. So it's every time it throws the energy up in an inductive way, the inductive energy wants to come back down. But when it comes back down, it bangs to the ground, and on its way up, it gets hit again. On its way up. So about a third up, it gets hit again. And you can hear it in one on the spark gap and two on the snapping, like popcorn. Crackle, crackle, crack, pop, pop. When I bring the 4-foot light near it, you'll hear that crackling. That's a resonant sound, according to Tesla in those lectures. And we're going to see that there's sparks coming out of these LED that I'm going to bring down there, and they'll light up and there'll be little sparks, and there's nothing connected to them. So that means that there's a phasing that's going on between the bottom of this pancake coil right here, which has 15,000 volts, 60 milliamps, and it's now reacting to the ground below it, plain and simple. Never thought of it, never counted it in. This is monumental far as going deeper, very deep. So we're connected to a 90-foot pipe over there. So our phasing is out of phase because we're banging here to the ground, but we're also banging down there down. So if you look at the ground itself has different potentials on every millimeter or 1/16 of an inch, however you want to look at it, has a difference of potential as you step apart. So if you were to be in a vehicle that has an electric line attached to it that fell out of the power line, and you get out of the vehicle, the first step out of the vehicle probably won't kill you. The second step will kill you. And if you were to take both of your feet and come out from the car and put your feet down and hop away, you have a better chance of surviving the disconnect between you and the field that's going on in that vehicle. Now, trust me, this is just common sense, but who would know that the difference in spacing and surface area of the ground is related to what we're talking about. Let's fire this son of a bitch up. Let's get it going. I did mention that when you add air to your spark gap, it exponentially increases the everything. You ready for this? bad air. Air's off. All right, that was me having fun, guys. Let's give you some fun time now. Now it's experimental time. I'm gonna make the gap smaller. And let's do the test. First test, look at the electric. That's test number one, you see the electric. Number two, we got a loop here. And we're still going, we got lit, and we're about 12 feet apart. As soon as you can see, all right, so we got still lit here. We're pretty far away from the source. Still lit. Still lit. Still lit. We're probably about 80 feet away. 100 feet at least. All right, just went out. Just went out. Back on. All right, so here we go. So I'm about right here. It just dimmed out. I'm about 4 feet off the ground. And now I'm gonna come off the ground. You can see it's getting lighter, lighter. I'm going up now. Let me get it from spinning on us. And I'm up in the air about 7 feet in my hand, and it's bright, and as you go down it turns off. So there was the test. You had a couple of tests there, and now we're going to go get that rebar. Alright, we're going to take the rebar, stick it in the ground. Look at that. Off the ground, LED. Now you've seen when I did that test that it wouldn't light up from the ground zero that I speak about and 4 feet up. There's like the densest part of everything. The nitrogen falls to the ground, the humidity's down there. Now I'm back again on the ground. I can't see just like you guys. So I'm just touching the probe to the piece of metal. And that's to the ground. Anywhere I put a rebar into the ground, I'm getting a closed loop circuit. Over here you can see. Stab the ground. Lit up. It's hard for me to see, but it's lit up everywhere. Let's go out the gate. And let's stick it in this hole. Go turn this thing off. Turn the beast off.